Hello everyone, my name is Nyat, and today I'm introducing to you guys about the simple applications of Cauchy-Schwarz inequality. So firstly, what is Cauchy-Schwarz inequality? Let's consider the case of two positive real numbers, a and b. We have a simple equation, a squared plus b squared is larger or equal to 2ab, which also means that 2a squared plus b squared is larger or equal to a squared plus 2ab plus b squared, which is a plus b totally squared. So what interesting about this is that it is the Cauchy-Schwarz inequality, which is, in this case, I split the number 2 into 1 plus 1, so that it will become 1 plus 1 multiplied with a squared plus b squared, each larger or equal to a plus b over d squared. The equality holds when a over 1 is equal to b over 1, which also means that a equals to b. Yeah. So the a and b is coming from square root of a squared and square root of b squared, while the 1 on the bottom, which is the square root of 1 and 1 in the inequality above. So this also can be generalized into an equation like this in the pink one. And the equality holds if and only if a1 over b1 is equal to a2 over b2 equal to the n to the an over bn. Yes. Okay. So the first application, direct application to an inequality. So let a1, a2, dot to an be the real numbers where the sum is 1. Prove that a1 squared plus a2 squared plus dot to an squared is larger or equal to 1 over n. So the solution is we have a1 squared plus a12 squared plus dot to an squared multiplied with 1 plus 1 plus 1, which has like n numbers of 1, so that we can apply the Cauchy-Schwarz inequality here. So we have it is larger than the first term is a1 because it is the square root of a1 squared multiplied 1, so it's be a1. The second term will be square root of a2 squared multiplied by 1, which is a2, and just go on and until an. So it will be larger or equal to a1 plus a2 plus dot plus an totally squared. Therefore, n multiplied by a1 squared plus a2 squared plus dot plus an squared is larger or equal to 1 squared because the sum of these n real numbers are 1. As such, we can prove that a1 squared plus a2 squared plus dot plus an squared is larger or equal to 1 over n. The equality holds when a1 over 1 is equal to a2 over 1 equal to dot equal to an over 1, which means that all these numbers are equal to each other. Okay. Moving on to the next application. Application on each term in a product or sum. So suppose x1, x2 plus 2x49 are real numbers, such that x1 squared plus 2x2 squared plus dot plus 49x29 squared is equal to 1. Find the maximum value of x1 plus 2x2 plus dot plus 49x49. Okay, so here's the solution. So we just multiply the sum of square root that we get on the question with 1 plus 2 plus 2.9, so that we can apply the Cauchy-Schwarz here. So we have the first term will be square root of x1 squared multiplied by 1, which is x1. The second term will be square root of 2x2 squared multiplied by 2, which is 2x2, and just go on and until the end is 49 square root of 49 x 49 squared multiplied by 49, which is 49 x 49. Yeah, therefore we have the following second one, which is 1 multiplied by 49 multiplied 50 over 2, which is larger or equal to the square of the sum that we need to find out. Therefore, the maximum value of the sum that we need to find out is 35 after you square root the number on the second line, last line. And the equality holds when x1 over 1 is equal to 2x2 over 2 equals to dot dot x equal to 49 x 49 over 49, which also means that x1 is equal to x2 equals to dot dot x equals to x 49, and we can use this and apply to the sum of square root at the question, and we have they all become 1 over 35. Okay, moving on to the last application. Let x, y, z, and w be the real numbers such that x plus y plus z plus w is equal to 5. Find the minimum value of this sum of square. Yeah. So this is the solution. You can see it. Yeah. So the basic idea is that you use 1 plus 1 plus 1 plus 1 multiplied by the sum of square that you need to find out, so that it can be larger or equal to the term that we get here, which is x plus 5 plus y plus 10 plus z plus 20 plus w plus 40 totally square, which we can apply with the question condition where x plus y plus z plus w is 5, so that we can get the answers. And the equality holds when x plus 5 over 1 is equal to y plus 10 over 1 equals to z plus 20 over 1 equals to w plus 40 over 1, which means that x plus 5 is equal to y plus 10 equals to z plus 20 and equals to w plus 40. You can use this and then apply it to the question condition, so that you can get that x is, so you can get the answers for x, y, z, and w. Okay, so this is an example that I want you guys to try at home. This question, the first approach, you don't need to think too complicated, just think simple and do it as simple as you can. If you still cannot find the answers, I can give you the answers, which is 12, so that you can check your answer after solving. So you can try different methods, and then you can see if your answers will be 12 or not, so that you can check if you're right or wrong and revise on it. Thank you for watching.